Hello everyone, welcome to Pratibha Tech. In this video, we will try solving the problem of the day question on Geek4Geeks for 2nd February 2023. The problem statement says largest sum cycle, which is based on graph and backtracking, and this has been asked in JusPay. Okay, so let's open the problem. Okay, so we will go through the problem statement clearly. Given a maze with n cells, each cell may have multiple entry points, but not more than one exit. Okay, this is like unidirectional doors like valves. Okay, you are given an array h of n integers where h contains the cell number that can be reached from cell I in one step. Okay, let's read it once more. You are given an array edge array of n integers where edge of I contains the cell number that can be reached from of cell in one step, of cell I in one step. Edge of I is -1 if ith cell doesn't have an exit. Okay. The task is to find the largest sum of the cycle in the maze. Sum of the cycle is the sum of the cell indices of all the cell present in the cycle. Okay, so we need to find the maximum sum possible in the entire maze. Okay, the cells are named with an integer ranging from 0 to n minus 1. If there is no cycle in the graph, then return -1. Okay, so we will be given a graph or a maze, and in that one we have to find the sum of the largest cycle that is present in that one. And if there is no cycle in the graph, then we need to return -1. Okay, so let's go through the example. So here it says the n is equal to 4 and edge array it is given as 1, 2, 0 and -1. So wherever there is -1, that cell is not having any exit, so we have to clearly ignore that -1. Okay, so here it will be 1, 2 and 0. So from position index position 0 we can reach up to 1, from index position 1 we can reach up to 2, and from 2 we can reach up to 0. Okay, so let's understand this one with an explanation. So we can depict it something like this. Whatever the array that is given there, 1, 2, 0 and 1. So it says like for going from index position 0 to 1, this is the way. Then 1 to 2 and 2 to 0. So it can be depicted like from one person can go from 0 to 1, then 1 to 2 and 2 to 0 again. So 0 is visited twice, so we can see that a cycle is being formed here. So from here 0 to 1, 1 to 2 and 2 to 0. So if we look at this one, then we need to find the sum of the largest cycle that is present in this one. So in this case it is 3, because it is 0, 1 and 2. That means this 3, adding this 3, it will become 3. If we look at the second example, then it is saying the edges are 2, 1, -1 and 2 again. So again, if we try to understand in that way, then here it is again index position, from at index position 0, from there we can reach up to 2, then 1, and we have to ignore this one. Then from 3 we can go up to 2, from 0 we can go to 2, 1 to 0, and from 3 to 2. So if we can see here, it will be like this. From 1 we can go up to 0, then from 0 to 2, then again we have to discard this one because it is -1. Then again from 3 we can go to 2. So here we can see that there is none of the node that is being repeated, so cycle formation is not possible here. Okay, so now we have understood the example. Also we have to solve it in time complexity of n and taking the auxiliary space of big O of n. Okay, so let's try solving it using the concept of DFS, that is depth first search. So first of all, we can create in this one, this is that starting point of the method. So we can create arrays to keep a tracking of which to keep the track of all the nodes visited and all the paths visited. So we can create an array, and that will be kind of boolean array saying yes, path visited and node visited as yes or no, something like that. Whenever we visited, we will mark it as true. So we can create like boolean, and this will be of course an array. So we can write node visited is equal to new boolean of n, because we have n integers there, then n nodes there. Then second one, again we can create another array for all the paths visited, because each of the time we will be first checking the nodes, then we will be seeing the whether that path is visited or not, because it is, since it is forming the cycle here, it's in the graph there, so all the nodes are connected with the path. So we can even check that visited is equal to new boolean, again we can write up to n. Okay, and for calculating sum, what we can do, we can create a variable here. We can just create a variable int sum, and we can initialize it with 0. Okay, fine. Now let's try solving this problem using for loop. First we will try creating a for loop with int I is equal to 0, I less than n, I plus plus. So we have to check every time that whether the particular node which we are referring, whether that is visited or not. So first we'll check node visited of I. If it is not visited, then we will start our searching in that one through the entire graph. So we will try creating one method here with the name, I'll just keep depth first search. Okay, and I need to pass that index position I, then I need to pass that array there so that I can calculate which all the nodes visited, and later in that method only I can calculate even the sum. Then we need to pass these two variables that we have created just to keep a track of all the nodes and path visited. So this, and again path visited, path control Z, copy and control V. Okay, so this is the method that we have created here. So this is ending up here. Okay, so till now it is fine. So now we will keep a track of this, and this is ending here. Okay, this method is there. So now we can create that method. We can say depth, same method name, whatever we have created here. Let's pass this. Then we will receive all the formal parameters that is being passed during the method call. int, then edge array, since it was an array. Okay, then again the same boolean type, boolean array of node visited, node visited, and boolean type of this path visited. So here we are receiving all the parameters that we have got from the above method call. Okay, just aligning it properly. Okay, so in this method, now we are going for each node. Now once we are reaching that one, then we can mark both of the node and path as visited. Node visited of that I is equal to true, path visited I is equal to true. So we are marking that we have visited the first set of node and path. Okay, so now we need to take care of the condition, taking care of the condition whether if any edge is -1, then we are not doing anything with that. We are completely ignoring that particular scenario. So we are just checking that if edge of I is not equal to -1, then we will do something here. In other case, we can mark path visited of that particular index as false, because since we cannot since the path is not having any exit, so we cannot visit that path. So we will be considering only scenario where the value is not -1. So here first we will find the value of that edge. So we'll call that variable adjacent. Okay, we can give any variable name, then edge of I, then we'll check if that node is visited or not. Node visited, this one. Okay, so here we are taking this scenario, considering the thing, the statement which has been given here, that means where edge of I contains the cell number that can be reached from off cell I in one step. That's why we are getting that value, and we are saying that once we are getting that value, we are checking whether that particular node is visited or not. For example, whenever we are getting for the index I is equal to 0, we are going up to we are having a path from 0 to 1, this one. So we are going to node 1, and then we are checking whether node 1 is visited or not. If you see in this diagram, then we are checking this one. Once we are reaching 1, then we are checking whether this is visited or not. Once we visit 1, then if we follow subsequently, then we can check 2 is visited or not. Similarly, we will be going ahead in this fashion. So that's why we're checking even whether that node which is the resultant of edge matrix of particular index, whether that edge is visited or not. So if that is not visited, then what we can do, we can mark it as visited. So we can do one thing, we can call this one recursively, this one, and again pass those same thing, but instead of I, this time we will pass this particular edge there. the adjacent variable there, because now we are not checking for index position, we are checking for the resultant of that index position in matrix in array of edge. So here now we will again passing the all those things required as it is. So it will be control C node visited, then here it will be path visited. So this way we are making sure that even that node can act as visited if this is not visited. But in case if it is visited, then we can check, then we will go to else block and see if that path is visited or not. Path visited of that particular edge. Okay, so we are checking with this path is visited or not. If the path is visited here, then what we can do, then we can mark that particular edge as we can just store the value in a variable saying int okay current, we can mark it as a current edge. We store the value here with edj. Then what we can do, now we have got that path visited, so we can keep checking this one, the current one, when the current is not equal till this edge. So because each time we will be having a different value there. So now we can just do a summation here. We will try running this in a do while loop, and we'll just try to do the summation of all the edges. Sum is equal to sum plus, we'll keep on adding this current to this one, then we will update the current with edge of current, see whatever we have got there in this edge that we are adding to summation, then we are updating this current and this current to edge of current, again the same reason as we had seen in this diagram. That means once we reach 1, then for this value we need to see whether we are reaching there or not. So this current is pointing to this one, but the current of that value that is pointing to, that will become this one, current of edge of current, that will be pointing to 2. Then similarly that way we need to progress. That's why we are updating the value of current till the point, till what point, till here, till the point current doesn't reaches the adjacent edge. That means that is the current edge in reference, then this one. Okay, so now we have taken care of this one. Then what we can do, this one is there. Now now we have to return the largest cycle. Okay, so actually we can store it in a variable, okay, that even that we can pass from here, saying it is expecting return type of long, so we'll create a variable of long saying the largest sum we need to take care of the scenario where if there is no edge, so we can mark it as -1. So we can return -1, so we'll initialize with -1, and the same we will try updating. Same we will try updating here, which will be either -1 or the summation of the maximum node here. So what we can do, we can write here math dot max of largest sum variable that we created, largest sum, and here the variable we created was sum. Okay, and this will be, okay, we have initialized it here. Okay, so now this method we can return the same largest sum variable. Either it will be this one or it will get updated in this depth first search method. So we can return, this method is ending here, we can return largest sum. Okay, so we are pretty well done with our coding. Okay, so let's try running and compiling it. Okay, it is giving some error in line number, okay, saying, oh sorry, we have not written any return type here. Okay, we are not returning anything, we are just updating the value of largest sum there. Okay, so return type required. Okay, fine, let's try again. Cannot find symbol sum. What we have done here, we have defined it here. Okay, one mistake here. Okay, so actually this is not required here. Let's comment out this one. Since we are calculating the sum each time for starting from the beginning till the value of current reaches the adjacent one, so we need to initialize it every time. And since we are returning the sum here, that is expecting the return type of long, we need to initialize with long sum is equal to 0. Okay, now let's try again. Cannot find symbol largest sum. Control C, let me check if max dot largest sum here, math dot max of largest sum, cannot find symbol. Let's try running it again. Okay, still we are getting some issue. Okay, sorry, since this is a method, this has to be declared as the global variable so that it can be used in both the methods. So that's my bad. Okay, this one. Okay, let's comment on this now. Let's try again compiling and running it. Okay, so this time we have got that answer. So we can try again with this custom one, the second example. For this one second example, it says in this fashion. Instead of this, I can edit it and try for the second example, that is 2 space 0 space minus 1 space 2. Let's run it. Sorry, compile and running. Okay, so we have got the required output as -1 because we do not have any cycle there. Okay, so now let's try submitting our solution. Okay, so we can see we have got all the test cases passed here. So we have successfully solved this problem using DFS. Okay, even the accuracy we can see it is 100%. Okay, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.